Hello everyone. In today's session, we are going to discuss about Quine McCluskey method. So if we consider a Boolean expression, the Boolean expression could be minimized using three different methods. One is Boolean loss, second one is K-map, and the third one is Quine McCluskey method. So Boolean laws are used when the Boolean expression has 2 to 3 variables. If the number of variables exceed greater than 3, then the complexity of using Boolean laws increases. So we move for K-map or Karnaugh map. These two methods has been discussed in my previous videos. K-map, when the number of variables in a Boolean expression is 4 to 5, K-map could be used. If the variables in an expression exceeds 5, then using K-map also will be complex. So we have to move to the Quine McCluskey method. So Quine McCluskey method or the tabular or tabulation method is the easiest way to reduce a Boolean expression when the number of variables is greater than 5. So before entering into Quine McCluskey method, let us see three important terms related to this. One is implicants, that is groups of ones is known as an implicant. Then is prime implicant, that is largest possible group of ones is known as prime implicant. The third one is essential prime implicant. This is prime implicant having at least one min term that cannot be combined in any other way. So this is the procedure of Quine McCluskey method. So in Quine McCluskey method, we'll be arranging the given minterms in ascending order. Then we'll be grouping it based on the number of ones present in the minterms. Then every member of the group will be compared with the successive group members. And if there is one bit variation in a position, then that will be replaced and will be represented by a dash, and then a prime implicant table will be formed. After that, essential prime implicants will be found, and the essential prime implicant plays a major role in finding the simplified Boolean expression. We can discuss this with the help of an example. Here I have considered only a 4 variable Boolean expression, that is the variables are w, x, y and z, and these are the minterms related with this. So first thing what we need to do is we have to write the binary value of the corresponding minterms. These are decimal values, and so we have to write the corresponding binary values. So this is the binary value from 0 to 15. We have represented it in binary form. And this is the number of ones available in every binary representation. Here no number of ones are there, so it is 0. Here the number of ones is 1, so it is 1. Here the number of ones is 1, so it is 1. Here the number of ones is 2, and so here I have mentioned 2. Similarly, here the number of ones is 3, and so here it is 3. Similarly, here the number of ones is 4, and so here I have mentioned as 4. So similarly, we have to convert the decimal minterms into equivalent binary and find the binary, find the number of ones from the binary. Okay. Now, the ascending order of these minterms is based on the number of ones present in the binary equivalent is written. So, if you consider the minterms, after 2, 6 is the minterm. So, if you consider the number of ones in 2, it is 1. If you consider the number of ones in 6, it is 2. But when we consider the number of ones in 8, it is 1. So based on the number of ones present in the binary value, we have to rearrange it in the ascending order fashion. So 2, 8, 2 and 8 both has, so here 2, then next to this 8, it has 1. Then if we consider 9, it is having 2. So all the other numbers have greater than 1 minterm. So 2, 8. Then coming to the next Minterm, the availability 6 is the next one. So if we consider 6 as number of ones is 2, right? Then 9 has number of ones 2. Then 10 has number of ones 2. Then again, if you see 11 and 14, 11 has number of ones 3, 14 has number of ones 3, and finally 15 has number of ones 4. So based on the number of ones, the midterms will be arranged in ascending order fashion. So see, actually the question is 2, 6, 8. The midterms are 2, 6, 8, 9, 10, 11, 14, 15. After arranging it into ascending order based on the number of ones available in the binary equivalent, it is 2, 8, 6, 9, 10, 11, 14 and 15. Now we have to make groups based on the number of ones present in the binary representation. So we have formed first group, right? So 2 and 8 has number of ones 1. So we have formed it in one group. 6, 9 and 10 has number of ones 2. So that is another group. And third group is it has number of ones 3. And this fourth group, the midterm has number of ones 4. So based on here, see the binary representation is also mentioned. So based on the number of ones, it is been grouped. So next is we have to compare every midterms with the successive midterm, and we have to find the number of bit that varies by 1 bit position. So in the first step, if you see, yes, so here you see this 2 and 8 are the group or one group. 6, 9 and 10 are the second group. So compare every element or every midterm of first group with the midterms of other group. So 2 has to be compared with 6, 9, 10, 11, 14 and 15. 8 has to be compared with the other cases. Similarly, 6 has to be compared with 2, 8 and the other group members 11, 14 and 15. So similarly, every particular midterm will be compared with other groups. So what we'll be comparing? We'll be comparing 1 bit position, change in 1 bit position. So if you see here, this is the 2 binary representation of 2 and this is the binary representation of 6 which belongs to another group. So I am comparing this 0, 0, 0, 1. Here a bit variation is there. This is 1, 1. This is 0, 0. So if you see here, only in this X, 1 bit variation is there between 2 and 6. So we have to consider this, and so 2, 6 becomes a pair. Yes, and see in the X we have a bit variation, right? In 2 it was 0, in 6 it was 1. So we'll be replacing this by dash. For this case, for W in 2 also W is 0, 6 also W is 0. If we consider Y, 2 also W is Y is 1, in 6 also Y is 1. If we consider Z, for 2 also this term, this bit is 0. For 6 also this bit is 0. So this is the only bit which varies, and so we are replacing it by a dash. Similarly, now the 2 has to be compared with 9. If you compare it with 9, 0 and 1. This is again 0 and 0. Fine. This is 1 and 0. So see here, a bit variation is there in Y as well as a bit variation is there in W. So which cannot be considered. Which cannot. 2, 9 is not a pair. If only one bit differ in only 1 bit position from the adjacent group, then only we can form pairs, right? So 2 cannot be formed a pair with 9 because here in W also a bit variation is there. In Y also a bit variation is there between 2 and 9. So it cannot be formed into a group. So again 2 is compared with 10. So see here, here it is 0. For 10 it is 1. So 1 bit variation. Here it is 0, 0. Here it is 1, 1. Here it is 0, 0. So only the W position, sorry, W position changes between 2 and 10. right? So 1 bit variation. So 2 and 10 can be formed into a pair. So see, only the W bit has changed. Yes, in the case of 2, it was 0, and in the case of 10, it was 1. So there we'll be replacing, because this can take either 0 or 1 when it comes to these two minterms. So that is replaced by dash, and then the remaining bits are 0, 1 and 0. Similarly, every group, after comparing 2 with all the things, then we have to compare it with 11, 14 and 15. This cannot be formed into group, because see here 15, when I compare with 15, 2 with 15, this is 1 bit change. And again, the x is also varying. So if 2 bits changes, then it cannot be considered to form a group. Then let us consider the minterm 8. 8 has to be compared with 6, 9, 10, 11. So if there is 1 bit variation between the binary digits, then they will be forming into groups. Similarly, group has been formed. Right, group has been formed. So 8 and 9 is group, 8 and 10 is group, then 6 and 14, similarly groups are formed. Okay, then coming to the next step, similarly we'll be dealing with all the minterms. Yes, all the possible groups has to be formed. Now again we have two successive groups of minterm which differ in only one bit position is again merged, right? Now 2 and 6 is compared with the next set 8 and 9. Then 2 and 6 is compared with 8 and 10. Two and the same procedure is again repeated. Here two minterms are combined together. So here we'll be having four minterms together. Right, now see, the number of group has been reduced. When it means that the number of group is reduced, obviously it means that the Boolean expression is also getting simplified. Yes, similarly it can be repeated if again the minterms or 1 bit variation is there between the minterms. Okay, so now see, the repeated redundant minterms can be replaced. Here we have 2, 6, 10, 14. Here again we have 2, 6, 10, 14. So these two are repeated cases. Only y and z is there. Both are similar. So replace 2 by 1. Only 1 we are using. Similarly here, these two are same. These two are same. So the minterms available here is same. So we can replace this by one group. Right? So here you see it is being replaced. Now we have formed, this table is known as the prime implicant table. We have formed the prime implicant table. Now from the prime implicant table, we have to form the essential prime implicant. We have to find the essential prime implicant. So see, the prime implicants, here we have expanded it, right? These are the minterms which is given in the question. S2, 6, 8, 9. These are the minterms given in the question. When we consider the prime implicant, y is it? If you see here, this is the prime implicant related to y and z dash, right? So see here, the prime implicants here are y, z dash. What are the things available? The first thing is y, z. Here it is 0, so z dash. And this is w and x dash. And for the third one, the prime implicant is w and y. Right, so we'll be getting 3 prime implicants. From the prime implicants, we have to form the essential prime implicants. So see, I'm writing this prime implicant below. So when you consider this prime implicant, write the prime implicants here. And for this prime implicant, for y is equal to 1 and z equal to 0, that is y z dash, the minterms related to this is 2, 6, 10 and 14. So 2, 6, 10 and 14. In some text it was mentioned as 1, and in some text it was written as x, right? Anyhow we can mention. So similarly for w x dash, the prime implicants are w x dash. The prime implicants are 8, 9, 10 and 11. So see, 8, 9, 10 and 11. Similarly, for the last case, the prime minterms related to this prime implicant is 10, 11, 14 and 15. 10, 11, 14 and 15. Right? So a prime implicant table is formed from the prime implicants. Right? Once after forming the prime implicants, we have to find the essential prime implicant. So essential prime implicant is the prime implicant which has only one in its column, only one in its column. So if you see this column, right here we have only one, and this here we have three rows in this column and only one is there, right? Similarly in this column also we have only one, right? Similarly if you consider this also we have only one, here also we have only one, right? And here we have three ones, so we will not find any essential prime implicants from this column. Similarly, here we have two ones and here we have two ones, which will not be considered for essential prime implicants. I've given the definition for essential prime implicant in the previous slides. And here in this column, see there is only one, and so that also will be considered. Now, the simplified Boolean expression will be, see, wherever I have found this essential prime implicant, the min terms or the prime implicant related to that essential prime implicant has to be noted. So, in this row, here we have marked essential prime implicant and the min term related with us yz dash. So, yz dash. And in this row also we have marked essential prime implicant. Essential prime implicant is marked based on the column, right? If only one is there in the column, then we'll be marking it as essential prime implicant. Then we'll be considering the min term related with this x dash, with this essential prime implicant. Similarly for the last column also. So see in this problem, if you see here, all the prime implicants which we have found form essential prime implicants too. But in all the cases, it is not necessary that all the prime implicants should be essential prime implicants, right? So in this problem, all the prime implicants are also essential prime implicants. And so this is a simplified expression using tabulation method. Don't you find it easy? So this is a four variable Boolean expression simplification. So obviously we can cross check it with a K-map, right? This is the K-map, right? Hope you know how to simplify Boolean expressions using K-map. If not, look into my previous sessions. So 2, 6, 8, 9, 10, 11, 14 and 15 are the min terms available. So we'll be marking all the values here in the K-map. Since it is 4 variable, we'll be having 2 power 4 cells, right? So see here, this is one YZ dash. This is the group that belongs to YZ dash. This is the group that belongs to WX dash, and this is the group that belongs to WX. So we get the same thing what we have achieved using tabulation method. You may be feeling that K-map is very simple. Yes, K-map is simple when it is 4 to 5 variables. If it exceeds 5, that is if the number of variables is 6 or greater than that, then K-map becomes very complex, and Quine McCluskey or the tabulation method is the best for the best when the number of variable increases. So this is an assessment for you. What is the advantage of Quine McCluskey method? Just have discussed. And what are the techniques available to simplify a Boolean expression? Thank you.